In this video, I'm going to provide an overview of one of the techniques that we use to assess data distribution within a dataset. There are quite a few techniques that are available to assess data distribution, but to help keep this video short, I'm just going to give an overview of one of the techniques. I'm going to use the software JASP to do this, not only because JASP is a very good piece of software, but it's free. And this presents you with the opportunity to install this on your own machines, then you can practice to reinforce your learning in your own time. I'd like to also bring your attention to some of the support resources. In particular, there is a textbook by Dr. Mark Goss Sampson, which is available as a free PDF. Early in the textbook, there is a link to a website where you can download all of the example data files, and therefore you can recreate the processes that are outlined in the book, confirming that you get the same results as those presented, and that will increase your confidence in the processes before you start to analyse your own data. This is what the software looks like before we pull any data in. I've previously downloaded a data file from Mark's website. I'm just now pulling that in. You can see that we're presented with 4 columns. We have a grouping variable and then 3 variables of data. If I click on the icon, we can see that we have our scales of measurement with interval and ratio grouped together as scale data, which makes sense because any tool that we can use for interval data we can also use for ratio data. In this particular example, we don't have any ordinal data, and this is nominal. And this makes sense because we only have the details of these numbers being in group 1 and the subsequent numbers being in group 2. Now obviously, as nominal data, the groups are only labels, and therefore we can be confident that nominal is the correct scale of measurement. I always suggest that before you do anything, you stop and look over your data just to ensure that things look like they're supposed to be. You shouldn't have too much reliance on your own opinion beforehand because we don't want to introduce researcher bias, but you need to have some sense about what the numbers could be. So for example, if variable 1 was referring to height, and I saw a value of 7.1 meters, I could be fairly sure that that's a typo and it should actually be 1.7 meters because I know what people's height generally is. If I look at the first variable, then we can see that there are some 700s, there are a couple over 1,000. Everything's sort of distributed within that range, so I'm not too concerned. When I look over the second variable, I see some 2s and 8s, some 7s. And then lower down, I see 1 that's less than 1. So we see here, if we come to 28, we have 0.54. So if I'd collected this data, I'd probably just go back to my original data set to see if that should actually be 5.4, because it's more in line with the other numbers that are presented. There are some techniques to assess if numbers should be classified as outliers. There'll be a separate video that's produced to help provide an overview of that process. Variable 3 has a few numbers less than 1, a few numbers that are above 2, everything distributed in that range, so there's no real need for concern. The top of the screen, then we have groups of different types of analyses that are available. I will be working through some more of these in future videos, but for today we're just going to focus on the descriptive statistics. When I move into this menu area, then we're presented with a new screen. If I look at the side, I have these 3 dots and I can just left click and drag if I need to refer back to my original data at any point. First sections ask us to organise our data so that JASP knows exactly which ones are information to be analysed and which ones are used to categorise it. So I'm not going to split into groups just yet because I'd like to just point out the speed at which the results section is updated. This is one benefit of JASP that I really do like. If I use SPSS, then I have to wait until I produce the PDF. It's often quite large and cumbersome, and it doesn't update in a live mode like this. You can see that there are some assumptions about the original statistics that need to be presented, but most of these are not fixed. If, for example, I didn't want to use mean and standard deviation, I can come down to the statistics section and uncheck those, and my live results quickly update. If I've already reviewed my minimum and maximum, I don't want these, I want the minimum amount. Again, I can uncheck these, and then perhaps I could look at a non-parametric type analysis, and my results are instantly updated. I can just copy these across if I wanted to move these into a Word document to write a report now. If you're not familiar with measures of dispersion such as the median absolute deviation and the robust version, There is a brief definition that's available to you when we use this little information icon, and you can see that you can scroll down and find definitions of these statistics. I'm not going to give an overview of descriptive statistics in this video. If you're not confident, please do read around or place a comment requesting videos on these, and I'll produce further videos on this later. The focus of today's video is on data distribution, and you can see there are three tools that are available for this. Skewness and kurtosis, we can use these measures, but they're much less common, particularly in my field of biomechanics, than the shapiro-wilkes test, which tends to be viewed as being a more powerful approach. So if I just place a check in the shapiro-wilkes test box, you can see that instantly we have the shapiro-wilkes value, which is kind of rare to actually see in a peer-reviewed article. People normally just focus themselves on the p-value. And you can see at the moment we have two values that are less than 0.01 and one at 0.65. The threshold for normal distribution is 0.05, and if it's less than 0.05 we consider that the data is not normally distributed. So at this point we would say that variable 1 and 3 are not normally distributed and variable 2 is. Let's have a look what happens if we split our data. We'll put that into the splits box, and you can see that instantly now each of the three variables is now divided into group 1 and group 2 based on that grouping column that's available in our raw data. Now you'll notice that we have 1, 2, 3 values that are greater than 0.05 and 3 that are less than 0.05. Now I could go in and I could check for outliers to see if that changed anything. I could look and see if I could transform the data to change all of these 3 that are below 0.05 to above 0.05 and allow me to use a parametric analysis. My personal preference is to not mess with the data as much as possible, and so I would opt to do a non-parametric analysis on this particular data set.